In this video, we will be solving radical equations. To do that, we first want to isolate our radical. So we're going to get it all by itself. In the first problem, we're going to subtract 3 from both sides. And we get the square root of 2x minus 3 equals 5. And then to cancel the square root, we can square both sides. And squaring cancels the square root, so we end up with 2x minus 3 equals 25. Now notice we did not need a plus or minus in this case. When we square root both sides of an equation to cancel a square, we need a plus or minus. But when we square both sides of an equation to cancel a square root, we do not need a plus or minus. Okay, so we continue to solve from there. We add 3 to both sides and we get 2x equals 28. Divide both sides by 2 and x equals 14. Now with radical equations, you always want to check for extraneous solutions because sometimes they have them. So we're going to check our answer by plugging it back in. So 3 plus the square root of 2 times 14 minus 3, and we want to know, does that equal 8? So if we follow up order of operations and go inside that square root, 2 times 14 is 28 minus 3. We get the square root of 25. 3 plus the square root of 25 is 3 plus 5, which is 8. That does equal, 8. Okay, next example. In this one we have a cube root, but we'll tackle it the same way. We're going to get the radical all by itself, so we're going to add 4 to both sides. We get 5 cube root of x plus 1 equals 15. We divide both sides by 5 to cancel the 5 and get the cube root all by itself. We get the cube root of x plus 1 equals 3. And now to cancel a cube root, we're going to raise both sides to the third power. So the cube root and the third power cancel out. We get x plus 1 equals 27. Subtract 1 from both sides, and x equals 26. And we'll check our answer again to be safe. So 5 cube root of 26 plus 1 minus 4. Hopefully that equals 11. We get 5 times the cube root of 27 minus 4, which is 5 times 3 minus 4. 15 minus 4, which does equal 11. So we're good. The answer worked. Okay. The next example gets a little trickier. In this one, we're going to move the 5 over to the other side to isolate the radical, and we end up with the square root of x plus 7 equals x plus 5. And now we're going to square both sides, but when we square the right side, we have to multiply a binomial. Remember, we can't just square the x and square the 5. This does not equal x squared plus 25. Does not. We have to write x plus 5 times itself and FOIL or multiply those binomials. On the left side, we do just get x plus 7. So I'm going to FOIL, and we get x squared plus 5x plus 5x plus 25. And now we have x's, an x squared, constants, so we're probably going to hope that this is factorable and try and solve by factoring. So I'm going to move all the terms to one side and combine like terms. There's nothing to combine with the x squared. I'm going to add the 5x and 5x to get 10x, but then I'm also going to subtract x from both sides. And that will give us 9x. And then we're going to subtract 7 from both sides, and 25 minus 7 is 18. And now I'm going to try and solve by factoring now that I have 0 on one side. So x plus 6 and x plus 3 should work. And then my two answers will be x equals negative 6 makes the first factor 0, and x equals negative 3 makes the second factor 0. But again, we want to check our answers. So first we're going to check negative 6. I take negative 6, I plug it into the original equation, and see, is it equal on both sides? Does negative 6 satisfy the equation? Negative 6 plus 7 is 1, so square root of 1 minus 5 is 1 minus 5, and 1 minus 5 is negative 4, which does not equal negative 6. So this is an extraneous solution. It doesn't work. Let's check negative 3, and hopefully that one works. So negative 3 plus 7 minus 5, does that equal negative 3? Negative 3 plus 7 is the square root of 4 minus 5, which equals 2 minus 5, and that does equal negative 3. So that one worked, and that's our only answer. The next example is a little more complex. And I'm going to promise not to put one like that on the unit test. So if you want the added challenge, try number 4 yourself. If you don't worry about it. But your hint in number 4 is that you should isolate the more complex radical first. So if you isolate the square root of 2x plus 1, and then square both sides, you'll get rid of one of your radicals, and then you're going to have to isolate the other radical. So get the square root of x all by itself and square both sides. So it takes some elbow grease. So good luck to you.